The next problem is assignment problem, where we have certain resources that must be assigned to certain projects, okay, in such a way that we minimize the total cost or total time required to complete the tasks. That would be the norm. Usually that will be the case, minimization of cost or task time, but it could also be used with profit maximization. If you have consulting jobs and consultants, and each consulting job has a certain amount of revenue, and you want to assign consultants to the different consulting jobs in such a manner that you maximize your revenue, so that also will work. Now, assignment problem is nothing but a transportation problem with each supply being equal to 1 and each demand being equal to 1. That's it. Then you solve as a transportation problem. Then you get the assignment. Okay. And the way it'll work is that since transportation problem, because of the structure of the problem, integer answers are guaranteed. And because of that, the answers will be integer. And with supply being equal to 1 and demands being equal to 1, all the transportations will be just 1 or 0. So a 0 transportation would mean that that particular assignment was not made, and a transportation of 1 would mean that that particular assignment was made. Okay, so here, so we have 3 workers with different talents and are able to do the jobs with different time estimates. Okay, and then so 3 workers and 3 jobs. And the owner estimates wage cost for the workers on the projects, and we want to minimize the total cost. So here is the setup. So we have 3 workers. So each worker can be assigned to exactly 1 job, 1 project. So here is the projects. So 3 projects. So again, the balancing is important. So if you have more supply or more people than jobs, then it's not a problem. But if you have more projects than people, then you have to add a dummy person. So any project that gets assigned to that dummy person means that that project is not going to be done. Okay, so these arrows, the numbers that you see for each arc, is the cost of making that assignment. Then we will be minimizing cost, but it could very well be profit or revenue generated by that assignment, and that also, if that is the case, then you will maximize the objective function. Okay, so let's do this in Excel now. Okay, so here is the problem. So first let's enter the costs associated with assigning each of the worker for each of the projects. So these are the wages. So let's format this. Okay, we don't need the decimal places, and let's do that. Okay, so here the supplies are just simply 1, 1, and 1. So and it is balanced, so we don't need a dummy supply. And the demands are 1. Okay, let's put the border here. And that would be our changing cells. Okay, and this works exactly like transportation problem. You sum the supplies, and that should be less than or equal to, or you can even, because they're all ones, you can even set it to equal to 1, and that will work too. Okay, and here we sum the column. Okay, so that will be how many assignments, how many workers will be assigned to the project, and that must be equal to 1, because exactly 1 person should be assigned, no more, no less. Okay. And the objective to minimize is sum product of the costs of assigning and the actual assignments made. Okay. So let's make it currency and color code it as objective function and color code these as input values. All right, so now let's go ahead and solve. We are minimizing the total cost. That's our changing cell. And shipped is that. All right. And received should be equal to non-negative simplex LP and solve. So now we have Adams will be assigned to project 3, Brown to project 2, and Cooper to project 1. So wherever there is a 1, that's the assignment that's made. So you get each project gets exactly one person assigned. So each person gets assigned to exactly one project.